This is the fifth video. The value of the integral, closed integral, 2z plus 5 divided by z minus 1 by 2 times z square minus 4z plus 5 dz over the contour mod z is equal to 1 taken in the anti-clockwise direction. So there are three things that we need to see, note exactly in the question. The first is that this is the closed integral. The contour is the closed curve, mod z is equal to 1, and it has been taken in the anti-clockwise direction. So we begin by finding the value of the integral by working on the singular points. So the singular points can be found by equating the denominator to 0. Okay, so we find the singular points equating the denominator to 0. So let's do that. Z minus 1 by 2 times z square minus 4z plus 5 is equal to 0. Now with this we immediately get the first root, z is equal to 1 by 2. So this is the first singular point. Now we will have two more points from the second bracket, z square minus 4z plus 5. Now this is a quadratic equation, and this quadratic equation can be solved by using the quadratic formula. Now you're already quite familiar with that. We worked that out in the very first question of this paper set. You can use that. So minus b plus or minus root of and so on and so forth. So I'll leave that solving part to you, and I'll write the singular points over here. The points are 2 plus or minus I. So 2 plus I, 2 minus I. These are the two roots and they are complex roots. So you will have to note that. So z is equal to 1 by 2 is the only real root here. And you will notice that in the given curve, mod z is equal to 1, closed curve, z is equal to 1 by 2 is the only point that lies within this curve. So this is the value that we will have to use. Z is equal to 1 by 2. Okay. And to solve this integral, this function, we are going to use Cauchy's integrated formula. Cauchy's integrated formula. Okay, so in order to use this, what we are going to do is find the value of the integral by substituting the real value that we have found, the singular point that we have chosen, z is equal to 1 by 2, into the part of the function that is remaining apart from this. So we leave this factor out and we substitute z is equal to 1 by 2 into the other into the variables that are there other than this factor here. So that would be 2z plus 5 divided by z square minus 4z plus 5 at z is equal to 1 by 2. Okay, so in order to do this, we have, the formula says 1 by 2 pi I times this, 2z plus 5 divided by z square minus 4z plus 5 at the value z is equal to 1 by 2. But here is where you will have to note that the question says anti-clockwise. Now because the question says anti-clockwise, this term is taken to the power of minus 1. So 1 by 2 pi I becomes 2 pi I. That's why you will notice that in each of these, or at least in these two, you will notice that the term pi I is in the numerator. So here we will have to take the reciprocal. So let me just grab another piece of paper here to continue. Okay, so we have Cauchy's integrated formula, and let me write that down again. So we took the reciprocal, so that would be 2 pi I into the value of 2z plus 5. 2z plus 5 divided by z square minus 4z plus 5 at the value of z is equal to 1 by 2. Okay, so let's substitute and see what we get. We get that's 2 pi I times 2 into 1 by 2 plus 5 divided by 1 by 2 square minus 4 times 1 by 2 plus 5. Okay, so this is quite basic arithmetic, and I'm going to leave that part out to you and see what you get. I'm just going to do that directly. 2 pi I times, okay, so the numerator is going to be 6 divided by, okay, and the denominator would be, let's see, that's a square, minus 4, then that's 2. Okay, so we'll get here 13 by 4. Okay, so you solve that further to get 2 pi I times 24 by 13. And finally, we get 48 pi I by 13. So this is the value of the closed integral, and this option matches part B. That is the final answer.